Hi everybody. Today I'm going to show you how to do the 12-6 skills, and in 12-6 we're going to add and subtract rational expressions. Remember, a rational expression is a fraction that has a variable in the denominator, so by definition a rational expression has a polynomial in the numerator and the denominator. So we in 12, 4, and 5 we did simplifying rational expressions and then multiplying and dividing rational expressions. So now we're going to look at adding and subtracting. So those are the essential learnings. And what you have to remember is when you add and subtract fractions, you have to have a common denominator or a like denominator. So we're going to talk about, okay, what if they are like denominators? What do we do to add them up? And what if they're not common denominators? And what we have to do is use our factoring skills in order to determine common denominators. So we're going to do a little bit of review here back in the day. So think back to when you began to add fractions. And so if we had 2 sevenths plus 4 sevenths, notice that these denominators are exactly the same. That means that you can add these as they are. You would have 2 plus 4 over 7, which is equal to 6 sevenths. If you could reduce or simplify, you of course would do that, okay? So then, letter B is subtraction. And so again, you do have a common denominator, so you're ready to subtract. And so what you do then is you take 3 minus 1 over that 8, and so 3 minus 1 is 2, so you get 2 over 8. And then, of course, you're going to reduce that down to 1/4. So we're just trying to get your brain to go back in time and try to remember some of the skills. So, for example, in letter C, these are not the same. Okay? What we want to do is we want to find something called the least common denominator, which, if you were to count by 15s and 5s separately, the least common denominator is actually the multiple that is the same between the two. So for example, if I count by 5, 5, 10, 15, 20, 25, 30, 15, if I count by 15s, I go 15, 30. Okay? So then 15 is called the least common multiple, which is the number we want in the denominator. So then you need to take the 7 over 15. You want a 30 down here. So we're going to multiply both the top and the bottom by a 2 to get 14 over 30 plus, and then we're going to multiply here both top and bottom by 6. So we get 24 over 30. And so now these are equivalent, but we do have that common denominator. So now we're able to add 14 and 24, which I know you can do, over 30, so 38 over 30. Reduce that down to 19/15ths, if I did that right. Now, if you're not a good reducer, oops, sorry, you can't see that. Your ABC key works. You just put 38 over 30 in there. Or if you have a graphing calculator, you would put 38 divided by 30, math fraction is that first thing. Hit enter, and you get 19/15. So no excuses about reducing. So here again, we have a 7 denominator and a 2, and so 14 is going to be the common denominator, least common denominator. So I'm going to multiply this by a 2 over a 2, and then this by a 7 over a 7. So I get 10 over 14 minus 7 over 14. Which then we do 10 minus 7 over the denominator 14, which is 3/14. That does not reduce at all. So that's the basic concept, is we need to have a common denominator before we can add or subtract. All right, so moving to what ours are going to look like. So this is the next set of examples, and we are adding and subtracting, and these do have common denominators. So what that means is we're actually ready to roll with our operation. And so I'm going to kind of simplify this then. They have a common denominator, which means the denominator is going to be 3x. Add 5 and 7, and we get a 12. Okay? But now we're going to use our skills from 12-4 where we reduce and simplify. And so 12 divided by 12 divided by 3 is a 4. And so our final answer is 4 over x. Okay? So again, here we are adding. So common denominator, we have a y and a y. So we are good to go by adding. So now when we look at the top, we have a little 2 plus this binomial y plus 1. So we're going to combine like terms. I'm going to write this out. 2 plus y plus 1 over y. So 2 and 1 is 3. So we have a 3 plus y over a y. And if you want to just leave it like that, I forgot to box this in, that's totally fine. You cannot cancel these. This is a term. It cannot be canceled with a factor. These are like locked in together. So this is it. Now in math, we usually write the variable term first. So this is the best answer. Whoops, you can't see that. Right there's the best answer. Okay? Now, the next two examples are subtraction. And when you subtract, you need to be very, very careful. Okay? There is a common denominator, so that's all fine and dandy. Boom, boom. Which means that over here in our answer, we are going to have an x plus 2 denominator. Okay? Now this is a little monomial, so I'm just going to write 2x here. The operation between is a minus. But you see how this is a binomial? You need to group that. And so that's what it looks like right now. So what you have to remember is you have to distribute that negative into both of these pieces in the binomial. So I'm going to do this. We're going to distribute. And so now what our numerator actually looks like is this. 2x minus x minus 5 all over x plus 2. Now we combine these two. So 2x minus 1x is 1x. So our answer is x minus 5 over x plus 2. So be super careful with subtraction. Okay? So then on the next one with a denominator that's the same, we have an answer that is going to have 2x minus 3 in it. Okay, now I should have made that longer because that numerator is going to have some stuff. Now, this is actually a binomial itself. So it's like we're taking this binomial here minus this binomial there. So it looks like this without doing any simplifying. And I don't know, you guys, if you were to just ignore the bottom for a second, that top expression is from quarter 1. And you guys were really good at simplifying these expressions. So again, you got to be careful because this minus here is being distributed. So the way I think about it is I'm taking this like term 4x and I'm minusing the like term 2x. So if you take 4x minus 2x, you're going to get a 2x. And most people do really well with the first one. It's the second one they forget. Because really here, everybody, you have a 1 minus 7. Let me write that down here. 1 minus 7. That turns into addition, which is 8. So it's 2x plus 8 over 2x. minus 3. So you are good at combining like terms. You just have to be really careful when you subtract. So the next thing we're going to look at in this day 1 is what happens if the denominators are not the same? What do you do? And today they're going to be somewhat basic, and then tomorrow they just get to be a little bit more challenging. So anyways, if you have denominators that are different, what do you do? First, you're going to find the least common denominator, which we practice a little bit with just numbers. Then you're going to rewrite your fractions so they have the least common denominator in it. Then you're going to combine your fractions like you did up here, and then you're going to simplify your numerators like you did right here. You simplified the numerator to get this. Okay? So, here we go. If you look at the first one, these denominators are not the same. Not only do you have to get the numbers or the coefficients the same, but you also have to get the power of the variable exactly the same. Okay, so I'm actually going to rewrite this one over here because I want to show some work. All right, so just think about 28 and 7. You want to have the same exact number. Well, you know that 7 times 4 is 28. So basically what I'm going to do is I'm going to multiply this bottom by a 4 to get a 28. But this is a binomial up here, so before I multiply by 4, I need to be sure that I group it. So notice I'm going to distribute. Okay. Now, this side has an m cubed as its denominator. This side only has an m. So the left expression is missing 2 powers. So what I want to do now is I want to multiply the top, I'm kind of squished here, by 2 powers of m. So an m squared I need to multiply by. And then of course here I'm multiplying by m squared too because you have to do the same thing to the top and to the bottom. So what happens then is that it looks like this. So you have m squared times 1, which is m squared, over m squared times 28 times m, which is 28m cubed, plus 4 times this quantity. Let's not distribute it just yet. Let's just leave it like we see it, over 28m cubed. So you see how the denominators are now the same? Now we can do the numerator. So we're going to simplify the numerator. We're combining. So we're taking, I'm going to start over here. We have an m squared plus a 4m plus 4, because I have to distribute that 4, all over 28m cubed. Okay, so now before we're totally done, we need to look at the numerator and we need to ask ourselves, are there any like terms? And there aren't. Degree 2, degree 1, constant. No like terms, nothing can be combined. Now the other thing we're looking for is there a GCF between these 3 that I could pull out and then simplify with the 28? And there isn't. So this one is actually done. That is your final answer. Okay? All right, so looking at number 6, we have 9 over 8x squared, and again I'm going to write it over here because I'm going to do some work. And I'm actually going to leave myself some space now because I'm going to put my work there for the common denominator. And then I've got a 5 over 12x cubed. All right, so here we go. We need a common denominator. And we are looking at just the 8 right now and the 12. So if I count by 8s and count by 12s, whatever number I get to first is really my least common coefficient for the denominator. So I'm going to start with the biggest number, 12. 24 is the second multiple of 12, which 8, 16, 24 is also a number if you have your multiples of 8. So I want to get a 24 for my front number coefficient, and then see how this one has 2 powers of x, this one only has 3. This is missing 1 power. Okay, so first of all, let's get the 24. So in order to get a 24 down here, I need to multiply by a 3 on the top and the bottom. And then in order to get a 24 here, I need to multiply by a 2. And that's going to give us a 24 for our coefficient. Now let's look at the variable. This one here is missing 1 power of x. This one already has 3. This one only has 2. So I'm going to multiply the top and the bottom by another power of x. Okay. So what happens then, I'm going to go ahead and multiply the top together. So I have 9 times 3x, which is 27x, over 8 times 3 is 24. X squared times x is x cubed, so 24x cubed. And the skill down here is actually chapter 8, where you're multiplying monomials. All right, operation is a plus. Second fraction is 5 times 2, which is 10, and down here would be 24x cubed. Oopsie daisy, I wrote 12. I meant to write a 24 cubed. And so now our denominators are the same. So we can actually combine these two. So our next fraction, which is going to have a 24x cubed in the denominator, is 27x plus 10. All right? So now you're going to kind of ask yourselves, can you combine 27x and 10? And you can't. Then is there a GCF between 27x and 10 that you could factor out? And there is not. So this is done right there. Okay? All right, moving along to number 7. And number 7 is just another scenario. So basically, we're just looking at different scenarios and how to get a common denominator. And up at the top here, we're looking at 3x over 2x minus 7 over 5x to the 4th. So we're subtracting. We need a common denominator. These are not identical yet. So what do we have to multiply? So you're thinking about 2x, you're thinking about 5x to the 4th. Let's start with the 2 and the 5. Count by 2s, count by 5s. 2, 4, 6, 8, 10, 5, 10. So 10 is the least common coefficient between 2 and 5. So I'm going to go ahead and multiply to get a 10 in the denominator. And so again, what I'm going to do, I'm going to rewrite this so that I can write, so 3x over 2x. I'm going to give myself some space to do some multiplying there. And then 7 over 5x to the 4th. And let's just start with green. I want a 10 coefficient, so I need to multiply. I could put this on this side if I wanted to. So I need to multiply by 5 to get a 10x. So I'm going to multiply the top out as well. And then down here, I need to multiply by a 2 to get that 10. Okay? Then I need a variable power to match. So this second denominator has 4 powers. The first one only has 1. So it is missing 3 powers. So I need to multiply by 3 powers, which is x cubed, and multiply the top by the same. Now that's going to have 4 powers of x. This already has 4 powers of x. So now I have what I need to move to the next step. So now what I'm going to do is I'm going to multiply this numerator out. 5 times 3 times x cubed is 15x to the 4th. So 15. Okay, I'm out of lead. Just give me 1 second while I grab another pencil. Okay, here we go. So 15x to the 4th, 15x to the 4th over 10x to the 4th minus, and here I have a 14 over 10x to the 4th. So as you can see, we now have a common denominator. We are minusing, but we're minusing just a single term here, so we don't have to worry too much about our subtraction. So here's what our fraction looks like now. 15x to the 4th minus 14 all over 10x to the 4th. And then I'm looking up here to see if those are like terms, if I can combine anything, and I can't. The next thing I'm doing is looking, could I divide out a number between these two terms that's divisible or reducible by 10, and I can't, nor does this have a variable that I could divide out and simplify further. So that one is done. All right, moving to the next one. So again, I'm going to go ahead and rewrite it. We've got 11 over 3y plus, leaving myself some space, y squared plus 3 over 6y, and in fact I'm moving this little plus over further too, more in the middle here. Okay, so look at 3y and 6y. We need a common denominator, and the y's already match the powers, so we're just looking at the coefficient, and if I count by 3's, I get to 6. So this denominator, done. What I need to do is multiply this denominator by a 2. So if I multiply it by 2, I got to also multiply the top by a 2. And so that one is going to be it. All right. So if you look at the numerator, it's going to be a 22 over 6y plus y squared plus 3 over 6y. Now we have a common denominator, and we can combine the numerator. So we're looking at 22 plus y squared plus 3 all over 6y. Now we can combine the 22 and the 3 because they're like terms. So we're going to have y squared plus 25 over 6y. This is a degree 2 polynomial. It is not factorable. So we're just going to leave it like that because sometimes you can factor it and cancel with the denominator. But this one is done. Okay. So one more example for day 1 here. We're looking at 4 over 6x squared minus 6x over 18x. Okay, so again, every problem is this, you're looking for a common denominator. You want the least common denominator because that's going to make it easier for yourself in the long run. So I'm looking at a 6x squared and an 18x. If I count by 6's, I get to 18. So I'm going to leave the 18 here, but I'm going to multiply the top and the bottom by a 3. Now this side has 2 powers of x, and that one only has 1 power. And so this right fraction denominator is missing a power. So I need to multiply both top and bottom by 1 power. All right, so this fraction is now 12 over 18x squared minus 6x squared over 18x squared. And what I have is common denominator. So I'm going to go ahead and combine the numerators, which looks like this. 12 minus 6x squared over 18x squared. Now, this one has a little bit more. A couple things. One, I'm going to put the degree 2 term first because that's how we normally write it. And that 12 is positive. The 6 is the negative coefficient there over 18x x squared. So what I want you to look at right now is the numerator is factorable. So between the two terms, there's a common factor of 6. Okay? So what I want to do is factor out that 6. Now, because the lead coefficient is negative, in math we don't really like a negative lead coefficient if possible, and we can manipulate that. So I'm actually going to factor out a negative 6, which leaves us with x squared minus 2. So notice if I distribute back through, I get negative 6x squared, which is this first term, plus 12. Now divide that by 18x squared, and now we're using our skills from 12.4, and these two coefficients, they reduce down. So negative 6 reduces to a negative 1, and then the 18 then reduces down to a 3. And so we have a negative x squared minus 2 all over 3x squared. Okay, so that's one answer. Now, if you did not take out the negative 6, your answer would just look like this, negative x squared plus 2 all over 3x squared. Either one is fine. It doesn't matter. Technically, with the parentheses still left here, then that's not totally simplified, so this may be the best answer right there. Okay, but sometimes if you have this negative with this numerator, you'll just see a negative out front of the fraction, and then you'd have x squared minus 2 on top and 3x squared on the bottom. So these are actually all equivalent, which sometimes you guys aren't quite clear on that, but now opportunity to kind of see those. So that's 12-6 day 1. Your homework will be different scenarios and maybe things that I didn't show you exactly, but the concept is the same. You need a common denominator, figure that out, combine your numerators, and simplify correctly. All right? So I'm going to leave you with a little something. I want you to do me a favor, and as you're going about your days, if you see someone without a smile, why don't you give them one of yours, right? It's free. Okay? All right, we'll see you later.